Good morning and welcome to the AWS Education Research Seminar Series. Today we are excited to talk about transforming the way that scientists share data, and we have Ms. Christine Kirkpatrick with us. She is the Executive Director at National Data Service. A little bit about Christine: she oversees the San Diego Supercomputer Center's Research Data Service Division, which manages infrastructure, networking, and services for research projects of regional and national scope. She is a recognized expert in the implementation of research computing services with an emphasis on data science workloads as well as operational cyber infrastructure at scale. And with that, I'm going to go ahead and hand over the mic to Christine, but I did want to let everybody know that we will have a Q&A portion of this session at the end for the last 5 to 10 minutes of the session. And you can go ahead and put any questions that you have regarding the content in the question queue in the GoToWebinar tool. So with that, Christine, please take it away.
Hi, thanks for having me. I'm Christine Kirkpatrick, and I head the Research Data Services Division at the San Diego Supercomputer Center, and I'm the Executive Director of the National Data Service. Often research computing services are menu-based. We have storage, we have compute. I'm involved in initiatives that want to start with a proactive, user-focused discussion about what researchers are trying to do, and then work backwards to provide the services to meet those needs. Much of what researchers do when collecting and processing data-intensive science is not as streamlined as it could be. One of these key functions is collaboration, sharing data, managing data, and making data discoverable and fair. I'm going to walk you through projects at the different layers of CI and highlight many of the ways we're collaborating with AWS, from the bare metal to the people. The Open Storage Network is a project I help lead, sponsored by NSF. We recognized a gap in the national community. You've got programs for computation, programs for networking, but there really wasn't much for storage, and it still remains fairly balkanized with no real standard way of funding it or of doing it for a project. Our pilot phase project brings a little bit more than a petabyte of storage connected by 40 to 100 gig speeds across the nation. The thrust of the project is to figure out the socio-technical challenges of distributed yet centralized with the core support team management, as well as the policies needed around active research data. So not raw, but not yet archival, at the point that other collaborators need to use it. It will also operate as a commercial cloud cache and provide software for easy sharing and discovery. We have several use cases that will drive and demonstrate a range of features. Here are some contributed from our close partner, the Midwest Big Data Hub, hosted by the National Center for Supercomputing Applications, NCSA, and a partnership between several Midwest universities. The OSN use cases, I should say, span many topics in addition to these, and in a later phase, expected for end of this year or early 2020, we will invite more participants. So perhaps you can immediately see how useful it is to assemble a set of scientific data sets into abstract use case types. What we're doing here is to try and understand where our storage substrate fits in with the researchers' data sharing needs. So while most are enabling multi-institution collaborations here in this top blue square, there are reasons to use a resource like the Open Storage Network even for single institution research projects. And just here's a quick example of the use case being turned into a more of an activity diagram. This is for running experiment to site. Here's our slice and compute example, and so on and so forth. And we're finding that most of the people that we've spoken to that have these data sharing needs for research are falling into nicely into that first diagram I showed you. We're very proud to partner with AWS on the Open Storage Network. There are several ways being integrated with AWS is important and will benefit researchers. Here are 2 architecture designs we'll be working on over the next year. So for users who already have their compute environment inside of AWS, the data from the OSN can be uploaded to S3 using Globus, or by syncing to S3 using the OSN S3 compatible API. The benefits are, once the data is in S3, it will be cheaper to access from within the AWS ecosystem instead of downloading from the OSN every time it is needed. And the data will be accessible faster on AWS's own network and with less latency. AWS offers other advancements such as their edge computing devices, the Snowball and the Outpost. These devices are pretty neat. We have a few Snowballs in our data center and hope to deploy a few during our OSN pilot. The AWS Snowball can be used to ship large amounts of data to low bandwidth remote sites, as you see on the top, or to receive large amounts of data from remote sites on the bottom. The OSN's fast connection to Internet 2 allows data to be quickly transferred to and from S3, which could then be made to quickly available to AWS Snowball and shipped out to the remote site. AWS Snowball saves the OSN or the remote sites from buying expensive storage to ship, which may only be needed for a few weeks. Also, AWS takes care of the logistics of shipping and packaging of the storage, which is way out of scope for the OSN and most research computing groups. We have several activities underway as we build out the application and capabilities for the OSN. There are also opportunities to learn more and become involved. And so in our community, we know these acronyms well, but PERC is a really phenomenal conference that's taking place in July in Chicago. And actually, if you just Google PERC 19, you'll find it. Highly recommend it, especially for people that are in research computing. Draws not just people from academia, but also industry and government. And then, of course, SC is the Supercomputing Conference in November. And this year is in Denver. So we talked about the need for a storage layer serving researchers' needs. As an infrastructure person at an advanced computing center, I'm very connected to researchers' computing and storage needs, but both could be easier to use and could better support research workflows. This need is what drew me to several initiatives for building out and simplifying the process of using infrastructure. So I really like this analogy that comes to us from the Research Data Alliance. It talks about moving from the internet to the data net. And this is an example of where the data net is now in terms of the old internet. And hopefully that makes sense. But if you remember, for example, those of you that have been using the internet, say for 20 years, you might remember getting an email with an attachment, and there was no way to just view it from your email. You had to save it and then find the application and then open it up. And then along came helper apps, and now you can seamlessly just view an Excel spreadsheet from your email. And we have the exact same issue with the data net. It's very rich. There are tons of different things that compete, and that competition can drive better capabilities in the software, or some are customized for different communities. And the whole ecosystem is richer for all of these options, but there is a ton of little streamlining and glue between these things so that they work seamlessly. At the moment, it can feel like you still need to have a PhD in computer science to make all this work together. So the National Data Service, or NDS, and US National Data Service, I shouldn't be so ethnocentric here, was founded in 2015 with the goal of driving deeper integration of existing research data management software components and identifying gaps needed to achieve an interoperable DataNet ecosystem. We focused on three areas: large-scale data service interoperability, incubating of data projects, and then actually as a side effect of how good the platform was for it as a training platform. The NDS Labs Workbench was built by the NDS Consortium and is now done primarily by the San Diego Supercomputer Center, where I'm housed, and NCSA. NDS Labs offers a platform for experimentation and sharing of data management and analysis software with the ability to migrate containerized cloud-based environments where analysis requires scale. It makes it easy for researchers to use cloud-hosted applications without having to understand how to start a cloud instance or how to install applications in the cloud. Part of the inspiration was to find a way to make it easier on researchers using tools and data without needing someone helping over their shoulder to configure on their own laptop. It runs off AWS or our SDSC OpenStack cloud. It uses Kubernetes to orchestrate Docker containers, basically. It's being used by the University of Washington's Advanced Data Curation graduate course, the Einstein Toolkit Astrophysics platform, Think Chicago Student Hackathon, and many other workshops and hackathons. And we also created a special catalog for the NSF's EarthCube project that supports data and computational innovation in the geosciences. Here's an example of how it's being used for the TerraRep Phenomics platform. We built a custom catalog, which is really tiny there in the upper right, as well as made the data available. And the nice thing is, I mean, you could use it on your phone, but your phone is pretty small. But you can use, just a Chromebook or a netbook to do this analysis that, especially for these workshops where people would be trained on how to use the data and to give feedback, it would take, an hour or two of someone looking over your shoulder to finally get all the components working right, and never mind all the other, just the hassles of having to fix permissions and things. And it's been really nice for this group because they have feedback much earlier than they would have otherwise about the data they're collecting and about the tools they're making available. So CHEESE, first of all, this is the best acronym of any project I've ever worked on by a lot. So we're using the workbench for this other NSF sponsored project, and the acronym breaks down to Cyber-Human Ecosystem of Engaged Security Education. The interesting part is in the middle at the top here. So we have Kubernetes launch several containers to show what an ARP spoof attack looks like from the client and server perspective, so a student can see what is happening and understand how to stop it or protect against it. So it's not really simulated. I mean, I guess if there's no attacker on the other side, but you can really try anything that you could try on a live host. There are several more security topics on the platform, such as Heartbleed, and this group is working to add at least a new one a month and have many previous things that were done converted into this kind of architectural style of explaining how cyber attacks work. Basically, it's about sharing data via code and architecture of how an exploit works so that a student can experience it in real time. Understanding the behavior, how to diagnose it, and stop the intrusion or neutralize the infection. And when I asked my collaborators on the project if they meant, if they minded that I mentioned this, they said I could mention it on this webinar as long as I shamelessly asked for some starter credits so we could migrate to AWS. So anyway, so done. I did that. Okay, so you've heard of genomics, the microbiome possibly, and understand that decoding disease and increasing wellness will come from integrations of several types of omics. Well, one of those omics, maybe a lesser known omics, but very important one, is the metabolome. And that relates to the many systems in the body that have their own rhythms. So when middle-aged people complain about their, quote, metabolism, it's an oversimplification of many processes. So metabolites are the artifacts thrown off from these processes. Well, we're in the relative early days of its study, similar to the human genome in the 90s, before it was fully mapped. Researchers need not just a place to share their studies, but a way to search across them for new patterns and insights. And this is the architecture for the new cloud-based Metabolomics workbench. We're proud to partner with AWS via the STRIDES program that enables quicker adoption of cloud for NIH researchers. The icons on top and on the right side show AWS resources that are region-wide, in this case, US West 2. So you've got a few components here. The elastic load balancing enables the Kubernetes pods to be accessible to the internet. The Elastic Container Service for Kubernetes provides simplified deployment and management of Kubernetes clusters. And Lambda for serverless functions to perform admin tasks for the NDS workbench. And last but not least, the Elastic File System provides NFS storage for users' home directories and allows data to be shared between applications launched as Kubernetes pods. There are two types of EC2 autoscaling groups for the Kubernetes worker nodes. One for fault-tolerant services, that's the NGINX Ingress, the NFS client, and NDS workbench using EC2 Spot. Instances and the other for single instance services like the Jupyter Notebook and RStudio using EC2 reserved and on-demand instances. Each type of EC2 auto-scaling group is placed in one of three availability zones, so the US West 2A, 2B, and 2C, for a total of 6 EC2 auto-scaling groups. Separating the Kubernetes worker nodes into 6 EC2 auto-scaling groups allow for 3 availability zone fault tolerance and cost saving using EC2 Spot instances for fault-tolerant services. Pods are scheduled in the correct autoscaling group by using Kubernetes worker node tags and node affinity scheduling. SDSC is home to the NSF-sponsored Science Gateways Community Institute, SGCI. One of SDSC's most popular gateways is Cypress, which is a web portal to access compute for phylogenetic research. This new grant utilizes compute from AWS. So the NDS Labs workbench that I showed you is very tool-centric. So next we move to show how this would work for someone searching for data first. NDS Share seeks to use community exemplar software together to streamline access to data and its companion analysis, and to enable easier reproducibility of data-driven research. It has the same functionality as the workbench, but you navigate via the data and then jump into analysis. And so here are the three example data sets that you can see. You know, we're a supercomputer center, so everything's at scale. So we started out with data sets that were in the 70 to 200 terabyte range, things that you're definitely not going to pull down to your computer and then, you know, do some compute locally. We thought it would be a, you know, and it did turn out to be a very good test case for this. So the Renaissance simulations, this utilized 3 years of Blue Waters, which is our, at the moment, largest supercomputer in the NSF Exceed program, used 3 years of Blue Waters time to create these simulations. But the team is maybe 6 people, and so there's more science to be had out of these simulations than the lab could mine in all that time. And so the hope in sharing things this way is that someone would come and see how the analysis was done, read about it in the publication, look at the Jupyter Notebook in this case, to see, you know, how someone stepped through the analysis, and that someone might then tweak it a bit, look at different slices of the data, and then contribute back. And this is actually closer to the way someone will find the workbench pieces of the Metabolomics workbench. So along the way to simplifying the infrastructure via innovations at the application layer, I started to understand the need for research computing professionals to not just think about the research receptacles and software, but also what we're putting into them, the data. Over the past several years, we've seen data science become something distinct, but related to statistics and computer information and cognitive science. This coincided with the big data deluge age. We have more data now than we know what to do with. And as research computing people, we've been asked to not just store data, but to collect data. So these are a few of the many ways the data lifecycle can be described. Data science is distinct from data stewardship. While many research computing groups ignore the data perspective, we were touching it so much, we started to need to understand better the life cycle of data, as well as how to handle it so that it could progress in the cycle, as well as to be most useful in future uses. So for example, we would collect data sets via APIs and ask researchers what format we should use for keeping track of data provenance. This often just elicited a blank look. We would see publications connected to a data set at a specific moment in time, but not have any idea what or if we should be capturing a snapshot of that version so the research in the paper could be reproduced. Over time, I figured out that it wasn't just that I didn't know, but that they were not easy issues to solve, or that the experts were few and diffuse. In 2016, a paper was published that coined a sticky term for what everyone had been discussing related to the need for proper treatment of data. This was simply FAIR: findable, accessible, interoperable, reusable. There are several initiatives to be aware of that offer various resources for creating and maintaining FAIR data. There are people who hope they can pass making data FAIR to the library. This is a faulty assumption, as it's not just security people who need to understand security, right? Even my mom needs to know not to click on links in phishing emails. And the same with web accessibility before that. Everyone needs to know how to make materials they produce to be accessible. And this just improves the quality of web searches and the experience when everyone codes to standards. So to do this, we need greater awareness of FAIR and its techniques by everyone who touches data. We have multiple models developing for data stewardship, some only for pieces of it, some overlapping. A common environment enabling data-driven research and innovation around the world needs to be built collectively. That's where GoFair comes in. The Go in GoFair stands for Global Open. Of the more mature models, or it is one of the more mature models, even though it's only about 3 years old, and it comes out of the Netherlands. It aims to avoid silo formation, undue competition, and fragmentation by fostering concerted verification efforts of its participants. This happens on the basis of 3 pillars: go change, go train, and go build. There are several implementation networks at different stages of development. You can see they're mostly in this go build area right now, but they do span the 3 pillars. And here we are this past January in Leiden for the annual implementation network meeting. We work on activities such as this matrix, which is, and you're not supposed to be able to read this. It's not that you have bad eyesight. It's very small, but it's a living document, and you can see each column is an implementation network, right? The rows are things like what are the metadata formats used, what sources are used for terminologies, and then we look across to see, and actually an easy one is pretty much everyone uses ORCID, O-R-C-I-D, to describe people. Or if they're not using it, that's ORCID is the thing that they would use if they were going to implement some. And so this makes it easy to guide how we would mold our training, our tool integration, etc. In February, I announced the establishment of a U.S. coordination office for the Go Fair initiative. We held our first data stewardship training in May and are working on a Train the Trainer workshop for early 2020. So more trainings can be held in the U.S. because at the moment, all the trainers are EU-based, and that adds a lot of cost to the workshop cost. While our focus is on Go Fair, we hope it will also serve as a nexus for other fair initiatives. Or to say another way, we are committed to serving the emerging needs of data stewards, funders, and researchers, and will utilize the best practices available from guidelines to training. While we see training as a key first step, not just to increase the number of fair data stewards, but to build awareness for the need for fair, we need tooling, even more than training, to make real progress, and it has to be really easy to do. We need hooks for data sharing as part of the scientific workflow, as easy as sharing a Google Doc or airdropping a photo from your iPhone. So this is a project I'm on called PressQT. We're not just building tools for open science, we're using the open science framework to document our work. This is supported through the Institute for Museum and Library Sciences, IMLS, and led out of Notre Dame with several other partners. This project complements existing repository infrastructure, aims to more deeply integrate workflow and software preservation tools, and expands our own and/or our early committed participants' previous work with an aim toward data preservation that facilitates scientific reuse and experimental reproducibility. Oh, and I should add, we're eating our own dog food, if you will. We're not only conducting a project to make these tools more available and easier to use, we're also practicing open science as part of doing this project by using the OSF platform. So at the people layer that connects researchers and resources, as well as connects across sectors, is the NSF Big Data Innovation Hub program. The 4 hubs correspond to census regions. It was just announced last week that each was renewed for 4 years, and I'm the deputy director for the West Hub. So we cover everything from Montana to New Mexico, and then west, including Alaska and Hawaii. The hubs build and strengthen partnerships across industry, academic, nonprofits, and government. We are proud to partner with companies like AWS. Some things that we work on include, things that try to spur economic development, address societal and scientific challenges, and accelerate innovation in the big data ecosystem. And actually, I'm on a Big Data Hubs assignment. I'm actually broadcasting from the National Library of Latvia. So if you were thinking, you're imagining that people are speaking in a different language behind me. I am actually from broadcasting at 6 p.m. here, and this is the best internet in the whole country, apparently, is here at this venue, where we've all gathered to create transatlantic partnerships with people from the EU, the European Commission's Big Data Value Association. So we have several workshops and co-sponsored events. In July, we're having a workshop in Las Cruces, New Mexico on big data and water. And in September, we're having a data science and carpentry primer for Hispanic serving institution STEM leaders in Seattle. And in particular, I hope you'll consider joining us for the All Hub Infrastructure Working Group. We meet every first Friday for a demonstration and discussion of CI, cyber infrastructure, related to infrastructure, software data, or people and big data. You can see our almost 40 past webinars on this YouTube playlist, right? That link at the bottom. And this slide deck will be available after, as well as the recorded video. So you don't have to rush and write everything down at the moment. If you'll be at PERC, that conference I mentioned in July, please consider signing up for our reception. I did want to say for the projects that we're partnering on with AWS, especially the Cypress one that was mentioned, you may wish to contact Dr. Sanjay Pati at AWS, who's been our strong collaborator and just extremely helpful in trying to innovate in the way we interface with commercial cloud. So thank you for tuning in. I know, especially for the West Coast, it's fairly early, and I'm happy to take any questions.
Hi, Christine. This is Marcy. I'll go ahead and read some of the questions that we have in the queue. So it says one of them was, will the slides be available after the presentation? I can go ahead and answer that. Christine, I believe that you're okay with us sharing those, so we can go ahead and post them on our webpage. So yeah, those should be up, as well as the recording of the session should be up within the next week or so. So you can look back to the AWS Education Research Seminar Series webpage to go ahead and find those resources. Let me go to the next question. That one seems to be a technical difficulty. This one was about the background noise, which you went ahead and explained. Yeah, we were all a little baffled about where that was coming from. So, you know, I guess having to do our best with locations. So no worries there.
Yeah, the librarians pointed me to the basement, which is like very desolate. But it turns out when it's closing time for a lot of people, and so it was Grand Central for about 10 minutes, so sorry about that. Although, if you wanted to know what Latvian sounded like, there you go. It's only spoken by 2 million people, as I understand it, so it's maybe not easy to come by.
Okay, great. And then I was going to read the next one. It says, we hear a lot of, quote, I don't want anyone viewing my data until I talk to them, or, quote, I don't want to release anything until after I publish 2 years from now. Do you have any tips for cultivating buy-in to the FAIR principles? So far, we have found it's not tooling, but rather the social/cultural factors that have led to a lot of resistance.
Oh, sure. Yeah, no, the technical problems are simple compared to the socio-technical problems. I guess I shouldn't say problems. That's kind of loading it up with negativity. So it's you know, it's not easy. I think it depends on the specific domain and the specific researcher. What I've tried to do is always show what's in it for the researcher. You know, and this has been comes about in different ways for academics, right? Not all academics would want to have their classes recorded and put online for their students, right? That was maybe my first encounter with people with a, quote, kind of a data sharing issue. And in that case, we had an instructor that was incredibly popular and wanted to take down all his podcasts because he thought my students won't come. And we said, well, actually, you're incredibly popular with truckers across the country, and you have this like double the audience because you're so interesting to listen to. People are just driving heavy equipment across the US, taking your humanities course. And so we've tried similar tactics with, I guess, appealing to somewhere between someone's vanity and their desire to do things, you know, do good. But also, I think people work so hard on these data sets, and you know, this is their life for a lot of them. And so when you can show that there will be some additional benefit that will come about from them sharing it, you know, I think that's important. Some of the, as far as embargoing I mean, there's some, specific guidelines and instructions depending on your funding agency. These are more at publications, but I do think that especially as we start to really try and tackle the issue of reproducible data, and as people start to see that that scholarship is not just a publication, but it's your data and it's your analysis workflow, right? Your Jupyter notebook or whatever documents how you got to your conclusions. That once that comes together, I think we're just going to see a more natural move to share data. And as we have more research, there's this whole movement of the quote research parasite, which people are very proud to say, I'm not collecting my own data. I'm just going out and using data that already exists to find new things. So we have some great examples. There's this one researcher at Stanford who has, several really important papers and discoveries on things from, tuberculosis to autoimmune diseases that have come from just the use of other people's data. And especially in the healthcare space, I think that a lot of researchers there are realizing that you can only study so many, patients, and that by putting your data in these commons, maybe even embargoed, so you wait a year before you do it, that you can get so much more out because you have access to everything else that's happening in that space. And that's definitely true of Metabolomics. What's interesting about working in that space is that it's like the early 90s before the human genome was mapped, and there are more metabolites than have been identified. I think estimates are that we've only identified in cattle 20%. And so in fields like that, it's just absolutely critical that people work together. But yes, no, I think that is one of the most important things that we need to address, and unfortunately not often funded, how to change culture, which is difficult.
Yeah, and we at AWS are doing our best to help researchers share their data as well. And so, putting documentation and codes in GitHub. And then we have RODA, which is our registry of open data sets on AWS, as well as the AWS Public Data Sets program for them to look into if they need some other resources. So thank you for answering that, Christine. I'm going to go ahead and move on to the next question, which is at the beginning of your talk, you alluded to the socio-technical aspects of the data cyber infrastructure science context. Can you say a little bit, could you say a little more about what you perceive to be the sociological challenges? Put another way, how do you convince either an individual scientist or a science community to move their established ways of doing things to a cloud environment? i.e., it's more than just saying that data is too big.
Right. So I think we've found a few things that worked. So you never get enough, all the money that you need to do research, and it's so hard. It takes so much time to apply for grants, and the acceptance rate is so low, and those dollars so important when you get them, that I think, especially for sponsored research, it's highlighting the ways that researchers can save money so that they can put more money towards labor. Honestly, I mean, you just never have enough people time for what you need to do, and that's always what gets shorted. So when I joined research computing, people always wanted to buy their own server, right? And one of the reasons is that you don't pay overhead, or like the tax from your institution that pays for lights and people to process the award and all that. And so one of the things that I've talked to researchers about, and again, not coming from the perspective of everything's got to be in the cloud, more from the perspective of this is how the money from your grant will go the furthest. And we made a really important change at UC San Diego, following on the heels of one at University of Washington, which is we were able to put in a cloud waiver. So we said to our, basically the general accounting office and to the CFO of the university, it costs you money to power and cool these servers that everyone is buying for their grant. but they have no financial incentive to go to the cloud instead, because you will tax their, their cloud credits at maybe 60 to 70% on some campuses, on top of the cost of the cloud credits. And so when we explained it that way, and we showed some of the statistics about how much energy, a server takes in a year, it was a very easy, and that conversation has not gone as well in other campuses, but it was a very easy change. NSF, and I believe with some help from AWS and other commercial cloud providers, actually had a call out for a cloud coordination team for computer scientists out of size. And I believe that solicitation said that there would be no overhead paid, no overhead allowed to be paid on the cloud credits. And so that was another great way that one entity, the National Science Foundation, helped kind of push along that conversation at the couple hundred universities that apply for these kind of grants. So I guess that's the economic side, and yes, it's which is incredibly important and always a place I start. But also I think it's important to put yourself in the shoes of the researcher, and to try and, with everything that you know as a computing person, think what is the right thing for this project. And it might not be the cloud, although I think there's a lot of nice advantages to putting things in the cloud. But as long as you can come from that perspective and show either it will streamline things, or you won't have to worry about what happens if your server fails, and be paying someone to come in the middle of the night to fix it, and concentrate on past pain points of previous projects. That's what I'd recommend. And hopefully that answers the question.
I think it does. Thank you. If anybody has any more questions, please go ahead and feed them through the queue. We do have a few more lined up. One is how to collaborate better with AWS in an open way. Do you have any suggestions or thoughts on that topic?
Yeah, so I think I mentioned the STRIDES program on the Metabolomics workbench slide. So that's a program out of the National Institutes of Health, where they have dedicated people at NIH, just a few, who work with contact points. It's the commercial cloud providers, one of them being AWS. And I think that's a really interesting model, where you have a local cloud facilitator. So someone that you can, not that we don't trust AWS, I love working with you guys, but someone that's an objective third party that is just their job to facilitate. In the case of STRIDES, they collect feedback on different pilot implementations and pain points, and then they work with someone that's pretty highly placed, I believe, in AWS, who helps facilitate all those different issues. So that's at least one model in the research computing world that I think's working well. And it's also nice because it's, again, not something that's coming off of your grant, right? They have their own funding to help you get started. Other than that, I know in my own, in our own division, where we have people that need to be adept at using commercial cloud and everything under that DevOps umbrella, we've sent people to the AWS Invent, I think it's called, your November, sometimes early December conference.
Yeah, that's called AWS reInvent.
Oh, reInvent, sorry. Yeah, I have a pathological inability to remember the right name of something, but whole other topic. So that was a great way to, one, to initially kind of get baptized in how all these things work and fit together. And then for the people that can make it, they really enjoy going and getting the updates. Also, knowing who your AWS person is that covers your territory, and knowing the SE, I don't remember what you call it exactly, but the technical person that
SA, our solutions
SA.
architects.
Yes,
Yeah.
okay, yes, that. Those people are invaluable. I mean, even though so much is remote, right? Like I'm in Latvia right now, which is so random and so far away. It is still really nice because those local people will come and meet with you in person, and it's nice to have a face with the name, and it's just a little less awkward asking, what might feel like a stupid question if you know a person. And so I've enjoyed that a lot about AWS, that it's not always emailing, abstract services at. alias.
Yeah, absolutely, and thank you for giving your opinion on those types of engagements. We do also have our summit sessions, which are in various locations, and those can also have some research-related materials and sessions attached to them. So something to consider. I wanted to loop back to your pointing out that we are involved in the STRIDES effort with NIH. So our research group actually leads that the NIH STRIDES program. In terms of the AWS portion. And I just wanted to let everybody on the call know that if you are at an institution who's looking to get involved with that program, reaching out to STRIDES and letting them know that you're interested in learning more would be the first way to get involved. And then they would guide you through the process from there. So thank you for bringing that up, Christine. So we have a couple other questions. What's your opinion about the state of open science and research?
Sure. So I was, I mean, it's easy to focus on all of the negative aspects, especially like that one of the early questions about how do you get people to share their data when they have, you know, just a bunch of reasons why they wouldn't want to. But I had the chance to do a talk in Denmark in May about the state of open science in the US. And I did a bunch, before that I did a bunch of interviews with program officers and different agencies to talk to them about what they were doing for open science, and actually left me really heartened. What I learned, and this is maybe obvious when you think about it, is that people are doing open science, but they're not calling it that. Or people are making their data fair, but they're not calling it that. And so sometimes just taking a little bit of extra time to, you know, figure out what the motivation is behind something, or, you know, trying to recast it in terms, you know, is helpful. So I think the National Science Foundation is doing great things. Many of you might not know, but when you have an award and you have a publication that's, you know, related to the award, you have to deposit it in NSF PAR, which is their publication archive. And you don't use the copywritten version if it's going to be in, you know, a protected publication, but you use one of the later versions, not the final, but after it's been peer reviewed, and they keep it there for about a year. So there's, you know, an embargo period that protects the publishers, and it seems like it's something that they could expand in the future, hopefully, to include metadata about maybe associated data and where to find it. It wouldn't be a repository itself. NIH, of course, has been doing wonderful things with the data commons and with projects related to that, like the one I mentioned, the Metabolomics workbench. I think it's just very powerful. I mean, not just for our nation, but really the world, when you have all of that research compiled in a way that you can do analysis across it, you know, and paired with the tools are getting better and better and more user-friendly. I know because I can understand some of them. Some of this scientific software is just mind-bending. And then, of course, we have the Office of Science and Technology Policy, I think OSTP, which is under the White House. 2013 was really, you know, a before and after year, because that's the year that the Holdren memo came out that talked about how all agencies that give out research funding needed to make sure that they were doing in a way that encouraged open science. And so there are many outgrowths of that, and some of the ones I've just mentioned are either related or direct outgrowths. But you know, I hope over time we can catch up to where the EU is and where Australia is with their commitment, and more importantly, the funding that goes with these initiatives.
Great, thank you so much for that answer. So there's one more question. What is the role of research computing / IT people with this change in data sharing?
Sure, so thank you for asking, and I talk about it to anyone that will listen. But research computing for the longest time has been, you know, people who are sysadmins, and that's very important because we have to keep, you know, clusters and large storage arrays going and manage all sorts of, you know, complex situations. But I also think it's time for us to, as I mentioned on that slide where, fair data is everyone's job. It is important that research computing people understand data and not just, do these massive, rsyncs between systems, but, to think a bit about the context, because, researchers have so much on their minds, so much that, they have to hold in their, brain that is their computer. And having to be a specialist in data management and some of these other things is just, on top of some of the science, practically you do need to be a computer scientist. Like if you think of astrophysics and what it takes, the computing behind that. That's why we have so many astrophysicists at supercomputing centers, because of the technical skills needed, and the limitations that have to be overcome to make a lot of this analysis possible. So it's just not fair to put that burden all on the researcher. And I think it's really important that research IT people continue to diversify, just as IT used to just be one person. You were, the web person, the system administrator, you were the programmer. Well, research computing needs to diversify as well. And we'll see people who are data stewards. That also might span people in the library. But we need to have people that are specialists and also specialists in doing this in a cloud-informed or cloud-centric way.
Fantastic. So I did want to go ahead and ask, were there any other points of interest or suggestions that you can offer for the researchers out there that are hitting the same pain points that you maybe have already navigated? Any words of wisdom?
Sorry, words of wisdom for, did you say other researchers or computing people?
Either or, whatever you'd like to speak to.
Well, this is just my maybe more personal philosophy and not even about anything technical. I think it's so important to every now and then look up from your screen and think about what is your goal and what is the strategy that you're using to reach that goal, and then go into the tactics that you're going to do to implement that. It's so easy to get on some of these projects and it's like, well, this is what we did before, or this was our plan when we wrote this, but that could be 2 years ago, and there are new technologies and new advancements, and the more people can be flexible and open and thinking about the goal, not about the steps that they were kind of committed to and that seemed safe. I think that would lead to better outcomes, and I don't know, increased sanity, but for me at least, increased sanity. It's so important. That's why I love research computing, is you feel like you're part of something that will have meaning or impact for society. And so as much as we can remember, that's the point of what we're doing, and not to, have our ticket queue be lower, or to make, maintenance easier on ourselves, but it's really about supporting the research. In finding that meaning in what you're doing, it makes some of the annoyances a little bit easier to handle.
Great, thank you so much for giving us that feedback, and from your experience, I'm sure that comes to a lot of people as meaning a lot. Anything else you'd like to touch on before we go ahead and end the session? And if anybody else has any other questions they'd like to pass through the queue, happy to relay those to Christine.
No, I just want to thank everyone, and thank you for your patience with the background noise. Yeah, I could have gone into one of these conference rooms, but I was afraid after reading that story about the woman being locked on the plane in the terminal. I was really worried I was going to be locked here all night. So anyway.
No, we completely understand. We appreciate you being present for the session while you're traveling abroad. I know that can sometimes be challenging. For those who are listening, I'd like to let you know that if you'd like to subscribe to our mailing list to receive information about what we're doing with research in terms of AWS supporting research, upcoming sessions and events, you can subscribe to AWS-research-interest at amazon.com. I'm sending that through the chime for the webinar right now. So for those of you on the call, you can go ahead and get that there. I also did want to take a minute to let everybody know that we have our next session on July 31st from 8 to 9 Pacific time, AM Pacific time. And we will be talking about artificial intelligence and machine learning in pediatric biomedical research with Professor Judith Dexheimer, who is the Associate Professor at Cincinnati Children's Hospital Medical Center. So please mark your calendars so that you can be present for that session as well. And I'd like to give a huge thank you to Ms. Christine Kirkpatrick. We really appreciated your time today and all of the great information that you provided. So thank you very much for being a part of the series.
Sure, anytime.